This question is from GATE 2015 Mechanical Engineering paper set 1 question number 37. In a slab rolling operation, the maximum thickness reduction delta H max is given by delta H max is equal to mu square r, where capital R is the radius of roll and mu is the coefficient of friction between the roll and the sheet. If mu is equal to 0.1, the maximum angle subtended by the deformation zone at the center of the roll, or is called bite angle, in degrees is dash. We have the relation given as delta H max is equal to coefficient of friction whole square into radius of the roll capital R. Now there is another relation of diameter and bite angle with the thickness reduction delta H. That relation is given as delta H max again is equal to diameter into 1 minus cos of bite angle theta. So we can equate this to mu square r. We can equate the equation 1 and 2. So we have mu square capital R is equal to diameter can be written as 2 times radius of the roll. So 2 times radius into 1 minus cos theta. To find out cos theta, let's rearrange. First we can cancel out r from both sides. So we'll have mu square by 2. Thus we will have cos theta equal to. So cos theta is taken to right hand side. On left hand side we will have 1 minus mu square by. Let's put the value and calculate this. We have cos theta is equal to 1 minus 0.1 whole square by 2. This calculates to 0.995. But we need to calculate theta. Don't write the answer as 0.995 by mistake. So finally we have to calculate theta by taking cos inverse. So finally we have the value of theta as cos inverse of 0.995, which comes out to be 5.73 degrees. Let's fill in the answer. Maximum angle subtended by the deformation zone is 5.73 in degrees. To learn about rolling process in detail, you can refer to the NPTEL video Metalworking Processes Rolling from the course Fundamentals of Manufacturing Processes by Dr. D.K. Dwivedi. He is from Mechanical and Industrial Engineering, IIT Roorkee. I hope this solution will help you clear your doubt. Thank you.